Okay, I'm going to go through the 9.5 to 9.6 quiz just to clear up any issues. So, first of all, just know that your questions might have been in a different order because the quiz is set up that way. So first, for this version's question 1, we're going to write as a single logarithm. So first of all, these are both base 5. So then when we put these together, they'll be multiplication. So it'll be log base 5 of 50 times 2.5. The only thing here is a lot of you left it as 50 times 0.25. But I was kind of looking for the simplified where it was log base 5 of 50 times 2.5 is 125. So the answer I was looking for was 125. And then as far as finding the answer when you evaluate, you can do it a couple different ways. You can either rewrite it in exponential form, and so we're going log base 5 of 125 equals something. So 5 to the something equals 125. And so our answer should be 3, because 5 cubed is 125. You also could have rewritten it with the change of base formula and done log 125 divided by log 5. And if you do that, you will also get 3. For the second question, we are expanding in this case, or actually really we're looking for what's equivalent, but typically that means we're going to be expanding. So if we do that, we have two terms being multiplied, so we can add them when we expand. So we have log of b to the 5th plus log of c squared. Is that anywhere? No. So now I'm going to move the 5 out front and the 2 out front, and I have 5 log b plus 2 log c. Is that there? Yes, it is. There we go. So our answer is D. And none of the other ones work because we didn't get it from expanding or changing how it looked. So writing an expression equivalent to log base 3 of 5, we're doing the change of base formula. All this means is we can use any base we want. We typically use just log base 10 because it's just log. And then we can do the outside over the inside or the bigger one over the smaller one. So log base 3 of 5 is equal to log 5 divided by log 3. And then if you want to find that, you would put it in your calculator. But then the equivalent expression, there'd be a 5 here and a 3 here. I changed up my routine, though. I have to have it rainbow and be consistent here. So log 5 over log 3. And that's just one of those rules. So if we had log base 8 of 73, we could rewrite this as log of 73 over log of 8. The numbers don't matter. It's the outside over the inside or the bigger over the smaller. For the next one, rewrite as a single logarithm and then simplify. Our answer won't have a log. Okay, so I got some crazy stuff going on, but I do know that if I'm rewriting as a single logarithm, I'll want to condense it or kind of squish it together. And for that purpose, addition goes to multiplication. So these are both log base b, and if we multiply these terms together, we'll get b over 5 times 5b. To make this kind of look nicer, and line it up and make this 5b over 1. So then we will get log base b of 5b squared, sorry for my pause, zoned out for a second, over 5, which is log base b of b squared. So then what we have is, if that equals something, we're looking at b to what power equals b squared. So our answer is 2, because these have to match. For this next problem, 6 to the x equals 32. So since we're rounding to the nearest tenth, we're going to have to use our calculator. It's pretty good, pretty safe guess. So if we have 6, oops, I'll never answer yet, I can't do rainbow. If we have 6 to the x equals 32, the way we solve these is we have a variable in the exponent, we don't want it there. So I'm going to take the log of both sides. So then I'll have log of 6 to the x equals log of 32. What is log 32? I don't know. But I can keep solving. And now this is x log 6 equals log 32. And now if I divide both sides by log 6, I can get x by itself. So x is log 32 over log 6. And in our calculator, just make sure you, if you have the calculator I'm using, make sure you use parentheses or the calculator will get confused. Log 32 divided by log 6. And again, just the log button is log base 10. So log 32 divided by log 6. And you should get 1.93. But be careful here. Round your answer to the nearest tenth. So our answer then should be 1.9. Now we'll solve for x again. This is the type where you want to look for a common base. The goal is to be able to set the exponents equal to each other. So I can rewrite 8 as 2 to the third power, and that's to the x minus 1, because I'm just replacing the x with the 2 cubed, equals, I can replace 4 with 2 squared, and that's to the 2x. And now we'll multiply. So we end up with 2, we'll multiply the exponents, I mean, and this is 3x minus 3 equals 2, and 2 times 2x is 4x. Now that these 2's are the same, we can just take 3x minus 3 and set it equal to 4x. If we subtract 3x from each side, we'll get negative 3 equal to x. So then x equals negative 3. Then we solve again. So I see this x minus 5 kind of stuck in there. I really can't get it out. And I can't really log each side because there's already a log. So let's rewrite it in exponential form. And if we do that, we can do 4 to the second power equals x minus 5. 4 to the second power is 16. And this is equal to x minus 5. If we add 5 to both sides, we get 21 equals x. So x is 21. Hopefully this has been helpful. If it's not helpful enough, please come to office hours today and we can talk about the quiz. Thanks.